Balancing chemical equations. In this video, we will be discussing how to balance chemical equations and the steps of balancing chemical equations. So, let's begin. Chemical equations are balanced according to law of conservation of mass. Total mass of elements in reactants equals total mass of elements in products. In other words, number of atoms of each element remains same before and after a chemical reaction. Here is an example of a balanced chemical equation. Zn plus H2SO4 gives ZnSO4 plus H2. You can see that the number of atoms in the elements in the left-hand side, that is the reactants, is equal to the number of atoms in the elements in the right-hand side, that is the products. Hence, the given chemical equation is said to be balanced. Steps in balancing chemical equations. Let's take the example of the given equation Fe plus H2O gives Fe3O4 plus H2. Step 1. Draw boxes around the formula so that you don't change anything inside the boxes as given below. Step 2. List the number of atoms of different elements present in the unbalanced equation as given below. Step 3. Start balancing with the compound containing maximum number of atoms. And select the element in that compound which has the maximum number of atoms. Here, as you can see, it is Fe3O4 and element oxygen has the maximum number of atoms in it. Hence, we have to balance O atoms. Balancing O atoms, the initial number of O atoms in reactants is 1 which is present in the compound H2O. The initial number of O atoms present in products is 4 in Fe3O4. In order to balance, the reactants is multiplied by 4 so as to get equal number of O atoms, that is 4 on each side of the chemical equation. An important point to note. Please remember that you can put coefficient 4 as 4H2O but not as H2SO4 or H2O whole bracket multiplied by 4. After step 3, the chemical equation we get is as follows, which is a partly balanced equation. Step 4, we now see that Fe and H atoms are not balanced. H atoms are balanced as follows. Initial number of H atoms present in the reactants is 8 in 4H2O and initial number of H atoms present in the products is 2 in H2. In order to balance, we need to multiply the product by 4 so that same number of H atoms, that is 8, is present on both sides of the chemical equation. After step 4, here is our partly balanced chemical equation. Step 5, we now move on to balance Fe atoms. The initial number of Fe atoms in reactants is 1 in Fe and initial number of Fe atoms in products is 3 in Fe3O4. In order to balance, the reactant is multiplied by 3 so as to obtain the same number of Fe atoms, that is 3, on both sides of the chemical equation. Step 6, we finally check whether atoms of each element of reactants in the left-hand side is equal to the products in right-hand side. You now have the balanced chemical equation. Step 7, we mention the physical state by writing the symbols. G for gaseous state, L for liquid state, S for solid state and AQ for aqueous state. Aqueous state means a solution present in water. Thus, the final balanced chemical equation along with physical states mentioned is given below. Sometimes reaction conditions such as temperature, pressure, catalyst, etc. are indicated above or below the arrow or both above and below the arrow. Examples are given below. Hope you learned the steps to balance a chemical equation. Practice more such chemical equations for a better understanding. Thank you for watching.